Inchara from Sri Venkateshwara College of Engineering under the Department of Computer Science and Engineering in Cyber Security. Today I am here to give a brief information about push down automata. Let us come to the introduction. The abbreviation of PDA is the push down automata. It is a type of computational model used in computer science. They extend finite automata by adding a stack for memory. PDAs are particularly useful for recognizing context free languages. Let us know its historical background. Guinnessberg, Gribbage, and Harrison in 1967 investigated stack automata, which are a generalization of PDAs. K. Vijay in 1988 described embedded pushdown automata in his doctoral thesis. By the end of the decade, automata theory was considered to be the pure mathematics of computer science. Basic definition of pushdown automata. It has merely 7 tuples. P is equal to Q, sigma, gamma, delta, Q naught, Z naught and F. Its transition function is equal to Q naught, sigma and Z naught. Let us know about the components of PDA. States sigma is the set of input alphabets, gamma is the symbols of the stack, delta is the transition function, q naught is the initial state, z naught is the start symbol of the stack, and f is the final state. Let us example for better understanding of PDA. The language goes like this. L is equal to a power n, b power n, where n is greater than or equal to 1. Here, the number of a's is followed by number of b's where the n value is equal. So, we have some accepted states like single B, double B, and triple B. For the following transition functions, we have considered triple A and triple B. So the transition function goes like this. Q naught comma A comma Z naught. That is Q naught is the initial state, A is the input symbol and Z naught is the top of the stack symbol. We get Q naught comma A Z naught. For the next function, A is the top of the stack symbol, so we get Q naught comma A A. The next function is also the same. Then we get Q naught comma B comma A. Here B is the next input symbol and A is the top of the stack. We get Q1 comma epsilon. As for 1A, 1B will be cancelled, so we get their epsilon. Next we have Q1 comma B comma A. Again we get Q1 comma epsilon. Again the same function will be repeated. Then when we have the last function like Q1 comma epsilon comma Z naught, which is the top of the stack symbol after all the number of A's and number of B's are got, we get Q2 comma Z naught. The transition function is like this. We start, then we have Q naught, Q1 and Q2. Q2 is the final state. The formal definition is P is equal to Q naught Q1 comma Q2, that is the number of states, and A comma B is the input symbols, A comma Z naught is the stack symbols, and transition functions are here, and Q naught is the initial state and Z naught is the top of the stack symbol and Q2 is the final state. Finally, Let us know the limitations of PDA. PDA cannot recognize all the types of languages. They are limited to context-free languages. They struggle with languages requiring more complex memory structures. The limitation highlights the need for more powerful computational models like Turing machines. Thank